In this video, we are going to look at the law of multiplication of probability. Let's say you carry out two different trials. First, you roll a dice. Upon rolling a dice, you get a 6, and this is event 1. Second, you flip a coin. Upon flipping the coin, you get heads. This is event 2. The occurrence of event 2 does not affect the occurrence of event 1. That is, the occurrence of event 1 does not increase or decrease the probability of event 2. That is, upon rolling the dice, if you get a 6, this does not increase or decrease the probability of getting head. It does not increase or decrease the probability of getting tails. Basically, these two events are independent of one another, and that is exactly why we call these two events independent events. So, independent events are such events that do not affect the probability of occurrence of another event. That is, when you roll a dice on one side and flip a coin on other, the outcome of rolling the dice does not affect the outcome of flipping the coin. That is why these two events are independent of one another. And in this case, if you want to find the probability of event A occurring as well as event B occurring, then you have to multiply the probability of individual event. That is probability of occurrence of A times probability of occurrence of B. And this is what you call law of multiplication of probability for independent events. For example, let's say upon rolling a dice, you get a 6, and upon flipping a coin, you get heads. So, what is the probability of getting 6 in dice and head while flipping a coin? It is equal to probability of getting 6 in dice times the probability of getting head after flipping a coin. The probability of getting a 6 is 1 by 6, your general formula for finding probability, and heads, it's always 50%, 1 by 2. This will give you 1 by 12. So this is the probability of getting 6 after rolling a dice and heads after flipping a coin at the same time. So we have a question right here. If we randomly pick a card from this deck right here, what is the probability of picking ace twice in a row without replacement? So you have a deck of cards and you are going to pick two cards in a row. The question is, what is the probability that those two cards you picked in a row, both of them turn out to be ace? And the cards you pick are not to be replaced. That is, once you pick the card is removed from the deck. The card is not again added to the deck. Now, as per what I have taught you, this is how you need to deal with this question. So basically, the probability of getting ace card first and ace card second is equals to probability of getting first ace card into probability of getting second ace card. Probability of getting ace card is equals to, there are altogether 52 cards in a deck and there are altogether 4 ace cards in a row. So the probability of picking an ace card is equals to 4 by 52. The same is for the second as well, 4 by 52, and this is the answer. But, this is completely wrong. This is wrong. Because this question does not deal with an independent event. This is what I mean. See, let's separate the question into events. In event 1, so you had your first pick. In first pick, the probability of getting first ace card equals to, so there's a total of 52 cards in the deck and there are altogether 4 ace cards. So the probability of picking ace in first pick is equals to 4 by 52. Now let's look at event 2. That is right after picking the first card, you pick the second card. So second pick. the probability of picking ace card is not equals to 4 by 52. The reason being, see, once you have picked ace in your first pick, the total number of cards in the deck now has decreased. There were 52 cards, now there are only 51 cards because one card has been removed. And since that one card that you removed is an ace card, now the number of ace cards remaining in the deck is also decreased. There were 4 ace cards before, now there are only 3 ace cards. So in this particular case, the outcome of event 2, the occurrence of event 2 is affected by the occurrence of event 1. And such events are called dependent events. So what are dependent events? Dependent events are the events that are affected by the outcome of one another. Dependent events are such events where the outcome or the occurrence of one event affects the occurrence of another event. Like in this scenario as well, the occurrence of ace card in the first pick affected the occurrence of ace card in the second pick. The probability of second pick was changed from the first pick. Now you apply the formula. That is the probability of getting first ace card in first pick and second ace card in second pick equals to 4 by 52, which is this one, right here, times 3 by 51, which is this one right here. And from this, the formula comes out to be the probability of event 1 or first ace card times probability of event 2 after event 1. Okay, one last revision for the whole thing. All right, so here's the thing. So we are learning the rule of multiplication of probability. Under rule of multiplication of probability, there are two different types of events that you know about, that you need to know about. The first are your independent events, where the occurrence of one event does not change the probability of occurrence of another event. And then there's your dependent events, where the occurrence of one event affects the occurrence of another event. For the first scenario, the probability is for A and B, it simply equals to the multiplication of both the probabilities. And in second case, the probability for the occurrence of both the events is equals to first the probability of occurrence of first event times the probability of second event only after the first event has already occurred.